All right, welcome everyone. If you are getting ready for that AWS developer certification, you know that the way Lambda talks to services like SQS and Kinesis is a huge deal. So today, we're going to unpack one of the most important pieces of that puzzle, the event source mapping. Let's dive right in. So let's start with a classic exam-style brain teaser. Picture this. You get a batch of 10 SQS messages, but one of them is a bad apple and it crashes your function. What happens to the other 9? The answer to this really shows why you have to master these configurations. Stick with me, because we're going to circle right back to this one in a few minutes.
So let's back up a second. What even is an event source mapping, or as you'll hear it called, an ESM? Well, the simplest way to think about it is as the glue. It's this AWS managed thing that sits right between your data source, like an SQS queue, and your Lambda function. Its whole job is just to read messages and then trigger your function with them, usually in these nice, efficient batches.
Okay, so that brings us to a really fundamental question. When we say something is reading from a queue, who or what is actually doing all that work? Let's find out. Here is a question that trips people up on the exam all the time. You've set up the mapping, you wrote your function, but what part of the system is actually checking that SQS queue over and over, looking for new messages? Is it something in your code? Is it SQS itself? And the answer is, it's the Lambda service itself. It has this sort of hidden fleet of internal workers called event pollers. You never see them, you don't manage them, but they are working 24/7 behind the scenes. And that's a key architectural point to remember. The polling logic is not your problem. It's not in your function code. And hey, if you ever disable the mapping, the poller just stops. All the messages in your queue just hang out, totally safe, until you decide to turn it back on. So now that we know who is doing the polling, let's talk about how we can control the data they send to us. This is all about tuning your settings to get the flow of records to your function just right. The first and probably most important dial you can turn is the batch size. How does this one little number really change the payload your function gets hit with every single time it runs? Batch size is pretty much exactly what it sounds like, but the key word to remember here is maximum. It's the biggest group of records the poller will grab before it invokes your function. For SQS, the default is a tiny batch of just 10, but you can crank that thing all the way up to 10,000. And that's a huge lever for throughput, right? Bigger batches mean fewer Lambda invocations, which means you process more messages for less money. It's a big win. Okay, now for a different kind of problem. Let's say you're processing a Kinesis stream, but it's not a fire hose of data. It's more like a slow trickle. You really don't want to waste a whole Lambda invocation on every single record. You want to be able to tell the poller, hey, just wait a few seconds, see if more records show up before you bother me. So what setting lets you do that? That magic setting is called maximum batching window in seconds. The best analogy is to think of a bus driver. If the bus isn't full, the driver might wait an extra minute at the stop to see if more passengers run up before leaving. This setting tells the Lambda poller to wait a certain amount of time, anywhere from 0 to 300 seconds, to try and fill up the batch. Your function gets called when either the batch size is full or the batching window time runs out, whichever happens first. All right, we know how to get messages and we know how to batch them, but now we get to the most critical part, not just for a production system, but for the exam itself. What happens when your code breaks? Okay, let's go all the way back to that first question I asked. A batch of 10 messages flies in. One of them causes your function to crash and burn with an unhandled exception. What's the default behavior for that entire batch? And here it is. The entire batch goes right back to the queue. That's right. Even the 9 messages you might have processed perfectly fine become visible again for another worker to pick up. And this can be a disaster, right? You're reprocessing things that already worked, which is inefficient. And worse, if your function isn't idiopotent, you could be creating duplicate data or all sorts of other problems. So that default behavior is pretty terrible. We obviously need a better way. How can we tell Lambda, hey, look, 9 of these messages were great, please just delete them. It was only this one specific message that was the problem. The solution is this fantastic feature called report batch item failures. When you enable this on your event source mapping, you're fundamentally changing the contract. Now, instead of your function just crashing, you can catch that error and return a special JSON response that just lists the ID of the one message that failed. Lambda sees that and says, got it, deletes the good ones and only retries the bad one. It's like surgical error handling. Okay, so that's SQS, but what about streams where order matters, like Kinesis or DynamoDB? Here you can get a nasty thing called a poison pill, a single bad record that fails over and over, blocking the entire stream.
Now, you could set a maximum record age in seconds to just throw away old records, but what if you want to isolate the bad record without losing data? For that, we have my favorite feature, bisect batch on function error. When you turn this on, if a batch fails, Lambda doesn't just retry the whole thing. It automatically splits the batch right in half and tries processing each half on its own.
And this process is just brilliant. Imagine a batch of 1,000 records fails. Lambda splits it into 2 batches of 500. The first 500 succeeds. Great. The second one fails. So Lambda takes that failing 500, and what does it do? Splits it again into 2 250s. It keeps doing this recursive binary search, cutting the failing batch in half over and over until it finds the single poison pill record, all without you having to write any code.
We've hit polling, batching, and error handling. Now let's just zoom out and look at the bigger picture. How does this all scale, and what other cool services can we plug into? Now, how Lambda scales its polling is totally different depending on the source, and this is crucial for the exam. For a standard SQS Lambda's pollers just scale automatically based on traffic. More messages in the queue, Lambda adds more pollers. Simple. But for Kinesis, it's way more rigid. Your concurrency is tied 1-to-1 with the number of shards in your stream. 10 shards means at most 10 concurrent Lambda invocations. So the takeaway is, to scale SQS, just send more messages. To scale Kinesis, you have to add more shards.
So what about other popular platforms out there? A really common question is whether you can use this same powerful event source mapping model with something like Apache Kafka, either self-managed or on Amazon MSK. And the answer is a big, definitive yes. Lambda has first-class, fully supported integrations for both Amazon MSK and even your own self-managed Kafka clusters. You get all the same awesome benefits we just talked about, the managed polling, the batching, the error handling. It makes building serverless Kafka consumers an absolute breeze. Okay, let's recap our toolkit for the DBA CO2 exam. Remember, batch size controls how many records. Maximum batching window in seconds controls how long you wait. For handling errors, report batch item failures is your scalpel for SQS, and bisect batch on function error is your detective for finding poison pills in streams. And finally, never forget this scaling models. SQS scales on traffic, Kinesis scales on shards. We have covered a ton of ground, from the secret life of the event poller all the way to advanced strategies for error handling. You now have the core concepts you need to build some seriously robust and efficient serverless applications. So the only question left is, what are you going to build with it? Thanks for watching.